Welcome. The Alligator is an on-farm nutrient capture and recycling device capable of removing toxic chemicals from freshwater bodies. Our group members are Matthew Hinchliffe, Omar Nouri, Eric Hole, Dolphin Chan, Sam Kanakin, and myself, Tanner Sheen.
As farming and agriculture has advanced, the push to increase crop resilience and yield has led to an increase in chemical fertilizers usage, and although effective, they do come with a cost. The main problems that our group set out to tackle are farmers losing fertilizer due to runoff and the detrimental effects these fertilizers can cause when reaching nearby water bodies. In these water bodies, the high concentrations of these chemicals leads to eutrophication and the creation of algae blooms. These algae blooms are not only responsible for the reductions of the water's oxygen content, but also for production of toxins that would render it non-potable for cattle and other farm animals. The farms of southern Alberta are no strangers to the effects of these algae blooms, their prevalence, and their continued threat. Initially, we brought our focus here as ground zero for our research and eventually testing. However, in the future, we would plan to broaden our scope. The balance of sun and precipitation throughout the region, while also lying next to the Rocky Mountains, leads to increased runoff, and for that reason has become the focus of our research.
Hilliard Farms expressed interest in the design, and an expert farmer recommended that we get the recycled fertilizer certified for crop safety to gain repertoire in the farming community. The Alligator electrocoagulation water filtration system was developed in order to address the problem of toxic runoff polluting bodies of water. Electrocoagulation is a system that introduces currents to a solution to precipitate target chemicals through the use of an iron anode and an aluminium cathode. The helical cathode design was chosen specifically due to its low maintenance cost. In addition, solar energy is used to negate any negative impact to the environment.
Water from the water body to be cleaned is pumped into the top of the electrocoagulation tank via a submersible 70-watt pump. Here, it will sit for a specified amount of time, during which an electric current will flow through the water to precipitate the contaminants thanks to the helical cathode and concentric anode. Once the designated amount of time is up, the treated water will flow down through the 3-stage filter to remove the sludge and can then flow back into the body of water or possibly be collected for use on the farm.
Our design is enclosed to protect the system from the elements, and is divided to separate the water filtration section from the electrical side with the inverter and battery for safety. The solar panel that powers the system is placed atop the system to be more compact and for easy accessibility. Since the SolidWorks design is built by assembly feature, most parts in the design can be replaced as they are worn out under an outdoor environment. The anode in particular is expected to be used up as it reacts via electrocoagulation in wastewater. Users can buy a replacement and install the components easily by themselves.
Although there are many methods of filtration, electrocoagulation has several benefits for our situation. These include reduced sludge production and the avoidance of using non-reusable chemicals that have to be disposed of after. The installation of our product will allow farmers to recapture nitrates and phosphorus from crop runoff instead of entering bodies of water and causing economic and environmental damage. As previously mentioned, electrocoagulation holds several economic advantages over other filtration systems. To give an idea of the benefit, we found a study that compared the operating cost of electrocoagulation to chemical coagulation, which is another popular method of filtration. They found that electrocoagulation has significantly cheaper operating costs, which shows its effectiveness for our needs. We also identified a 70-watt pump that would meet our product's energy needs for $89.99, and was estimated to have annual upkeep costs of around $37 per year, assuming the pump is used for 8 hours a day, every day of the year. Finally, we found solar panels ranging from $30 to $130 that would meet our needs, and this expense would be very infrequent since solar panels have an average lifespan of 25 to 30 years.
Now, as far as implementation for the electrocoagulation system is concerned, installing the device requires minimal effort as the system is placed close to the surface of the water and the intake pump rests at a slightly lower elevation to create water flow. Maintenance is relatively minimal as there are few components that deteriorate with a prolonged usage, with these components being the anode rod, filters, and the water pump, all of which are simple replacements. The frequency that the filters will have to be cleaned and emptied depends on the concentration of the nitrogen and the phosphorus in the water supply. The future of the Alligator depends on producing a physical product to test on real bodies of water to further understand where improvements are required. The recapturing of these nutrients would also result in the possibility of reusing said nutrients instead of having to purchase more fertilizer, thus alleviating some of the farm's fertilizer expenses and environmental impact. Finally, we want to determine how to reduce the size of the design, ultimately with the goal of creating a portable system This is going to be useful for farmers who have multiple small bodies of water spread throughout their land. Thank you for watching. Any questions, comments, or concerns?